So here we're going to fill out the graphic organizer for the states of matter. So I'm drawing my curve for what it's called a heating curve would look like as we go from a solid to a liquid to a gas. So I'm going to drop in some pictures of our water demo. So this is where we went from solid water or ice to liquid and then boiling. And so our boiling liquid shows both the liquid and the gas. So water freezes or melts at 0 and boils at 100. So anytime we go from a solid to a liquid, it's called melting. Every time we go from a liquid to a gas, it's evaporating. Going the other way from a gas to a liquid is called condensing. And going from a liquid to a solid is called freezing. We're going to look closer at solids here for a second. So particles in a solid are packed really tightly together. They're nice and organized. They're not always necessarily stacked directly on top of each other, but they have a definite shape and a definite volume. They're tightly packed. They only move a little bit. They have strong intermolecular forces, or IMFs. So that means they have strong attractions between the particles. So I said a minute ago that they move really slowly. So we're going to draw little lines that we call whooshies to show that they're moving. They're just not moving very fast. So now we're going to look at liquids. So liquids are a step up from solids. So the particles are spaced farther apart. They're moving a little bit faster. So we've got a little bit longer whooshies. Liquids have indefinite shape. So that means they take the shape of whatever container they're in. They do have a definite volume though. They can't be expanded or contracted or compressed. That's what I meant. So there's free motion in liquid particles. They have significantly less intermolecular forces. There's still some attractions holding them together, but they're just not very strong. And they're moving a little bit faster than solids. They're moving at a moderate speed. So as we go from a solid to a liquid, you're doing two things. You're increasing the motion and you're breaking the attractions. And as we go the other direction from a liquid back to a solid, you have to slow the particles down and you have to form those attractions or those intermolecular forces between the particles. So now we're going to take a look at gases. Gas particles are spread very far apart, especially compared to liquids and solids. They move very, very quickly, so they have long whooshies in the particle diagrams. Gases have no definite shape or volume. This means, unlike liquids and solids, they can expand and they can contract. Like liquids, they take the shape of the container that they are in. We assume that gas particles have no intermolecular forces or no attractions between the particles. And as we said before, they move very, very quickly. So now we're going to look at our different measurements that we use for our states of matter. And we have 4 main measurements that we use. We use mass, volume, temperature, and pressure to measure our solids, liquids, and gases. So mass we can use for all 3 states. And mass is defined as the amount of matter in an object. We can measure mass using a balance when we are in lab. Now, our units for mass are based on grams. Using our metric prefixes, we can also have milligrams, which is 1,000th of a gram, or we can have kilograms, which are 1,000 grams. Next, we have volume. We can use volume for solids, liquids, and gases. It's defined as the amount of space an object takes up or occupies. We can use different tools to measure volume in lab. We can use graduated cylinders, we can use beakers, we can use pipettes. It all depends on how precise of a measurement we want. We measure volume primarily in liters. Just like with mass, we can have milliliters, which is 1,000th of a liter, and we can have kiloliters, which is 1,000 liters. Next, we have temperature. Again, we can use temperature for all 3 of our states of matter, and temperature is the degree or intensity of heat present in an object. So temperature or substance. So temperature is related to the kinetic energy or the motion of the particles, and we use a thermometer to measure temperature. We use 2 units in this class. So we use Celsius, which is degrees Celsius or degrees C. Celsius is based on water. 0 degrees Celsius is the freezing point of water, and 100 degrees Celsius is the boiling point of water. And then it's just divided into increments from there. Kelvin is considered an absolute temperature scale, where 0 Kelvin means absolutely no motion, no particle movement at all. To get to Kelvin, we do degrees Celsius plus 273. Pressure is our last measurement, and it is specifically for gases with our states of matter. So you can measure pressure with solids and liquids, but it's not typical, and we're not going to in this class. So we're going to use pressure for gases, which is the continuous force exerted on or against an object by something in contact with it. So we're looking at the contact between gas particles and the wall of a container. We can use multiple things to measure pressure. We can use things called manometers or barometers. In this class, we're just going to use digital sensors. There are lots of units for pressure. The first is atmospheres, or ATM. The next one is millimeters of mercury, or mmHg. And then the last common one is called torr. So those are the different types of units that we're going to use for our different measurements. We're going to explore each of them a little bit further as we get more in depth and as we start using and applying these measurements in different situations.